All right, number 16. How do I read that? Log base what? 2 of 8. Okay, so what would that be equal to? 3. Let's take a break. Hold on, come over here. What's your understood log that base right here? 10. Okay, 10 to what power gives you 1 over 100? Negative 2. Very good. Log base 2/16 of 6. What's the relationship between these two? You're taking the what? Cube root. How do I write cube root? 1/3. Very good. Okay, this is something raised here. What's the understood base for this ln? E. That's natural log, isn't it? What happens to these two e's? And you're left with what answer? 7. What do you notice about these two? So what's your answer? 3. Very good. Are we good on that? Right? All right, number 18. Tyler, what did you get on this one, buddy? Log base 6 of 1 over 36.
Negative 6.
I know what you did, but that's not correct. What is 6? 6 what raised to what power gives you 36?
Squared. So.
Yeah, negative 2. All right, number 20, Derek. What did you get on that?
2.
Very good. Number 22. Kensley, what you get on 22? 2. Very good. 24, Kylie. 2. Those X's cancel out. Number 26, Jackson.
7.
Very good. No, is it 7 or 6? 6. 2 to 6. Okay, I want y'all to do 17 through 27. Right now, I'm going to give you a minute. We're passing red ribbons back. Just pass them all back. All right. Number 17, Mr. Lamar, what did you get? Very good. Number 19, Dylan, what did you...
1.
Yes, 1. Dylan, what did you get? 1. Very good. 17 and 19 are both 1. Nick, what did you get on 21, buddy?
3.
Very good. Jaden, what did you get on 23?
1
Okay, hold on now. You got to change that to 1 over 100. So what would be that 10 to... What now? Negative 2. That's your answer, okay? Negative 2. Number 25, Madison. What's your answer? Remember, what's your understood base on a natural log, guys? E. So these E's cancel out there. So your answer is 4. Number 27, Holly. What would you get on that one? Not negative 2. Negative what? 3, because 5 cubed is 125. Let's review that, man. What's 1 squared? 2 squared? 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? 12 squared? 13 squared? 14 squared? 15 squared? 16 squared? 256, 17 squared, 18 squared, 19 squared, 361, 20 squared, 21 squared, 441. Any of these can be liable to be on your test on the non-calculator part. On Friday, you have 2 parts of test. The first part will be non-calculator. That will be these problems right here. What we just did, non-calculator. And then after we're going to do that for 10 minutes, and then everybody turns that in, and you can take the rest of the test. Okay, 22 squared, 480 what? 484. 23 squared. 529. 24 squared. 576. 25 squared. Y'all remember y'all been tested on that since 7th grade? Guess who implemented that? So when you got to this class, we would know our squares. So there's always a rhyme and reason. 7th grade you do 1 through 15, 8th grade 1 through 20, then 9th and 10th grade 1 through 25. I don't give that test here because I figure. And you remember in algebra 2 you had to do the cubes? 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. As long as you know that, I don't give you much over 6 cubed. Those are the famous ones. I know that you were testing 1 through 10, as long as you know 1 through 6. All right. Now, let's look at number 28. Let's rewrite this in exponential. It'll be 3 to the what? Equals. Okay, let's go and write this one down. X to the equals. What's the understood base here? 10 to the second equals. The understood base is 10. That's known as a what logarithm? Common. What's your understood base here? E to the equals. Very good. Now let's rewrite these in logarithmic. Would I use log or natural log here? Talk to me. What? So let's make sure we understand. Be natural log. Do I need to write that E? No. It'll be natural log of 4 equals x. Check yourself. E to the x equals 4. How would this one be written? Log base. What will go here? Equals. Very good. What would I use here? Log or natural log? Do I have to put that 10 there? But if you did, would it be wrong? No. Will I use log or natural log on E? What goes right here? Equals. Are we good on those? Yes.
What were the answers for 28?
28 was 3 to the 4th equals 81. 30 was 10 squared equals 100. Are we good on that? Okay. That's our review, yes.
32 would have been wrong because that E was done.
On natural log, it's not common to do that. I wouldn't count them wrong right now, but try not to do that, okay? Alright, we're going to do a new learning target today. Read our learning target for us, please. I can graph logarithms. Now look at this beautiful poster I made watching TV yesterday afternoon. Yes, I do have chart paper at my house. I have it on my walls to help remind me stuff that I need to do next time. Alright, graphing logarithmic functions. The log parent function is f of x equals log base b of x. Look at this. If you notice, this is the exponential function. You see that? Look how these are inverses. You see how that goes? That's the shape of the logarithmic. Exponential, logarithmic. Now, you know that exponential and logarithm are inverses of each other. I want you to notice about the domain and range. In exponential, your domain was all what? Because they're inverse operations, the domain and range has swapped. Do you notice that? You're from being domain all real numbers, that's what the range is of a logarithm. And then in an exponential, your range was 0 to infinity. Well, now that's your domain. Do you see why they're inverses of each other now? Does that make sense? Yay or nay? We good? So just know, because they're inverse operations, your domain and range has flip-flopped, okay? Now, graphing logarithmic functions, we don't make a table. We use 3 very important points. Now, the base, one of your points will be 1 over that little number right there, comma -1. The same, 1, 0 will always be it. Now, you see the stress. That sounds familiar. Okay. Anything raised to 0 is what? 1. So on the exponential function, it was 0, 1, wasn't it? But see, on logarithmic, the numbers flip because they're inverse. So it's 1, 0. And the other point you would have is the base, comma 1. So those are the 3 points you would use to sketch your graph. And that's all you use, okay? Yes?
Well, 1, 0 changed because it, like transition.
You talking about transformations?
Yeah.
Yes. We're going to talk the first 2 that we do. Won't have any transformations, but if there's transformations, you would still write these three, and then from those points transform it based on what's in your problem, okay? So we're going to talk about that, okay? All right. So let's look at number 1 on page 3. We have log base 5 of x. Go and put your 3 parentheses down. That first parentheses is going to be 1 over the base. What's your base here? So I'm going to put 1/5, comma, negative 1. What's your second point? 1, 0, and then 5, 1. You said, Mr. Esther, why are those points what they are? Okay, let's think about this. Let's get deep for a minute. If I plug these points in here, like this, I'm going to take this first one. Isn't that the x coordinate right here? What is sitting in my x coordinate here? 1/5. 5 to what power gives you 1/5? That's why it's negative 1. You see that? If I plugged in 1, 5 to what power gives you 1? That's why that. You see why they are what they are? Okay? Now, we're going to graph them. You see, Mr. Esther, it's hard to graph 1/5, you estimating. 1/5, comma, negative 1. It's going to be very close to 0. 1, 0, 5, 1. I'm not going to, okay. I'm not going past that 0. Not going past that 0, okay? Now, I'd like to prove something else to you. Have you ever seen something like that? Log base 5 and negative 25. 5 to what power gives you negative 25? Anything? No, that does not exist. You will never see a negative number sitting there. You might see a fraction. You might see a smaller number. But you're never going to see a negative number. Logarithms are not defined for negative values. They are not defined for negative values. And this is the reason why. Look at the graph. Do you see it going over here in the negative values? So when I tell you that logarithms are not defined for negative values, this is why. Because there's an asymptote right there, okay? So that's why you will not see that over there. Does everybody understand that now? Okay. I just want you to know the reason why you won't never see that. Okay. Any questions on number 1? All right, number 2. What's going to be my first value? 1/2, negative 1, 1, 0, and 2, 1. That's what you would graph. Now you said, Mr. Esther, how am I going to remember this? You just got to go home and learn those 3 points. There's no tricks. You just got to know that you graph these 3 points. And I'm not giving you that on the test, okay? That's not going to be on your quiz on these, but you got to know those by test Friday. Alright, number 3. Here's my question for you. My base is 1/2. That's fine. But if I have 1 over 1/2, very good, it will be 2. 1 divided by 1/2 makes the half flip. So that will be 2, comma, negative 1. What's my other point? What's my other point? 1, comma, 0, and then 1/2, comma, 1. Okay. If you have your calculator, I'm going to show you how to graph this. The log button that you see on your calculator is only for log base 10. If it's not log base 10, you can't use that button. You have to go under math. If you're looking for something, it's always probably under math. And scroll down till you see log base. That's how you get a different log, okay? Oh, didn't mean to put that there. Okay, so that's what comes up. I'm going to change that. I went under math right here, and scroll down till I found log base. I'll come show you in just a second. You don't have that? Only my old one doesn't have that. That's why we have to teach graphing by hand, because some calculators. Some TI-84s, depending on how when you got yours. It depends on what year you got your graphing calculator or what type of it. So if you don't have it, it's not that big a deal, because I'm teaching you by hand right here.
You can get it updated.
You can, yeah, that's right. You could update it. All right. Now let's look. Okay, I want you to see the difference between the first three and the next three. All these didn't have anything in parentheses or on the outside, does it? You see here, I'm moving what? Moving the graph what? Up 1. What am I doing here? Moving the graph right 3. What am I doing here? Left 2. Do you see that? Yes.
Why does it only graph the bottom part of the graph when graphing calculator?
Because it's so close to 0, you can't see.
It's so close to that y-axis that it's blending in with it.
Yeah. It says error in the table. Oh, just kidding.
All right, number 4. So what you do on number 4, guys, is you list your 3 pairs just like you would. So that'd be 1/3, comma, -1, 1 0, 3 1. Just as if you were graphing that normal. Now, the +1, is that going to affect your x or y values? So what do you think I'm going to do? Add 1 to each of my y values. So -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. So those are the points I would actually graph on my graphing calculator. That's as hard as this gets. So if it's on the outside, you're going to apply it to the y. If it's on the inside, what do you think you're going to apply it to? X. So would you add -3 or +3 to each of them? Add 3. Because remember, when it's on the inside, it's opposite what you think. Bless you. Alright, so on number 5, what's 1 divided by 1/4? 4, -1, 1 0, 1/4, 1. What did I say we're going to add to each of the x values? We're going to add 3. So that would be, in fact, 7, -1, 4 0. And then you could just say 3 1/4. Because 1/4 plus 3 is 3 1/4. Now here's my question. Here's my question. Let's be careful here. Domain there's an asymptote, isn't it? Range, you don't have to worry about it. If it's going up and down, it's still going to be all around. But domain, in a logarithm, the asymptote was at 0. I shifted it. So where's my asymptote going to be now? 3. 3, so you got to be careful when you draw that. It's not going to go past the 3. Like I would draw it like that. Does that make sense? Get very close. So if you're moving it, shifting it right or left, you got to worry about how you draw that a little bit. Now we didn't write the domain range on all these. I don't know why I forgot to do that. What's my domain on this one? Number 1. My range. All real numbers. Yep. Number 2, your domain. Range. Same thing for number 3. Number 4, domain. Range, all real numbers.
Wouldn't it be different if it
Okay. Will the domain change or the range? That one dealt with the range, so your domain didn't change, did it? It was still approaching 0. So on that particular one, no, it didn't. On number 5 is where the domain was affected. Okay, we don't have to do number 6 because it's just like number 5. That's not too bad, is it? Yes, no.
Okay, so if it's in parentheses, it affects the domain and the x value, but if it's not, it affects...
It affects the y, but really your range won't change because it's always all real numbers.
No.
All right, tonight, guys, use tonight to make sure you understand everything at this point. You have 7 problems. 6 through 10 is graph and exponential. I promise this last night you have to graph an exponential. 6 through 10, exponential. If you get something really weird like to 100, like on number 9, but I don't think you do those 3. And then 36 through 42 is logarithmic, okay? Practice your graphing. You had other homework, but you remember how we just filled in that middle block of your paper? I took that off your homework because we could have done that together. That's what we just did. So you have 7 problems graphing logarithms, okay? Everybody good? Do we need to spend a full day on this again, or just review it partially? Domain is from 3 to infinity because it's shifted. Okay, I need a hand signal. Hand signal, how you feel on graphing logarithms? Okay. I'll spend probably 10 or 12 minutes reviewing the concept tomorrow and then go on into properties of logarithms. What now? Yes.
Like, but if there's a coefficient or something, I thought I knew that.
Yes, buddy.
Are we able to take keep unit 1 and 2, but take them out of our binder? Because I'm running out of the page.
No, you keep everything in your binder this semester.
Okay.
The next few units are not as thick as the first one. Oh yeah, okay. Here we go. Here's the red ribbon read. Today was stand up against drugs. Tomorrow's twin day. I'm gonna repeat these one time. Wednesday's decade day. Thursday's university day. Friday's game day. It's Halloween on theme for Friday's game. Like dress up in a Halloween costume. Wait till y'all see mine. I am dressing up Friday. So.
For Halloween costume on Friday?
I always have a list.
I'm not, well,
Yeah, last year Elise did her, and apparently, last year was, but it was like 2
could give you a test?
No, you're going to block on the
no, I'm probably going to do my good.
all white.
Hey, no, it's table. I have bagels. I love bagels.
Have a great day, okay? So hold on. Let's. Okay. Let me clear it from here. I just want. Let's make sure. When you're graphing exponential functions, your domain is always what? Domain is always what? The range is what you have to worry about based on transformations. In logarithm, it's opposite. Do you have to worry about domain in logarithm?
Yes.
Yes, but range is what? So just think about that when you're graphing stuff, okay? Does that make sense? You said, how many did these things about a graph on Friday on test? You got 3 exponential and 1 logarithmic.
I'd be mad if that was. I wasn't silly session.
You put your stars up. You put your stars up.
I was going to bring you the books. They're there for 6 hours.
And I picked the stars.
Dylan, I fixed that for you. Thank you, Mr. F.